Good morning, friends. We are studying shear force and bending chapters, and third type of the problems, that is can draw shear force bending diagrams of cantilever beams. So, last type of the varieties of all the problems, that is based on the cantilever beams. Today we will see. So after that we can start. This means remaining portions means from the shear force diagrams, draw load diagrams and bending moment diagrams. So that's why please note down. Draw the shear force and bending moment diagrams for the cantilever as shown in figure. Draw shear force diagram and bending moment diagram for the cantilever as shown in figure. Also locate the point of contraflexure. Also locate the point of contraflexure. (20 km, 3 meter, 2 meter). (3 meter, 2 meter). This is cantilever beam, 20 kilonewton per meter. This is uniformly decreasing load, 20 kilonewton per meter. 20 kilonewton per meter. And concentrated load, no, this is 5 Newton meter. Suppose this is A point, B point and this is C point. So that's why this is reaction A. Now RA equal to, so only this uniformly decreasing loads act. So that's why 20 into 3 this distance, and this is triangular type of the loads. That's why divided by 2. So there is no any concentrated load. So this is equal to 30 kilonewton. This is clear. So RA equal to 30 kilonewton. So that's why shear force calculation, shear force at A point equal to 30 kilonewton upward, and shear force at B point, this is equal to 30 minus 20 into 3 divided by 2. This is shear force. That's why 0. And shear force at C point, this is again equal to 0. And this is load is A, B, C. It's 30 kilonewton This is triangular type of the load. So this is nature of the curve is the parabolic. This is your shear force diagram. Now bending moment diagram. Bending moment calculation. First we'll see bending moment calculation. So bending moment at C point, this is equal to 0, and bending moment because couple acting at just left hand side of C point, this is equal to 5, and this is anti-clockwise, so that's why 5, this is kilonewton meter. And this is anti-clockwise. Bending moment at B point, again there is no any another moment, so that's why this is plus 5 kilonewton meter. Next, bending moment at A point. So this is the end point above the cantilever beam. This is plus minus. Now center of gravity, this is located, and this distance is the 1/3 of third. So that's why 20 into 3 divided by 2, this is shear force, and 1/3 of its distance. So this 3 will get cancelled, and this is 25 minus 30 equal to minus 25 kilonewton meter. So that's why this is this is constant 5 kilonewton meter, and this is 25 minus and this nature of the curves likewise. So this distance equal to, suppose x distance, and this distance equal to 3 minus x. This point is the point of contraflexion. All right. Now point of contraflexure. So that's why here figure this is 3 meter, 20 kilonewton per meter, and suppose, so we'll change this, we'll consider this is 3 minus x and this is x. This is correct. We'll see what happens. Suppose this is h and this is x. So that's why for small triangle I consider this distance equal to x. So where this bending moment. So that's why for 20 divided by 3, this is equal to, and this height h divided by x means h equal to 20 divided by 3 into x. And we are calculating bending moment at A point. All right. So we are interested this height into, so it's the center of gravity. All right. So try to understand this. So we are interested in these areas. This is h and this is x, and this distance equal to x third, because 1/3 above the distance, center of gravity. And this is equal to bending moment about this point equal to 0. So here h into x divided by 2 multiplied by, so this is shear force divided by 1/3 of x minus 5. No, this is clockwise and this is anti-clockwise, that's why this is plus 5 equal to 0. Now h equal to 20 by 3 into x multiplied by x, this is x divided by 3, and this is 2 plus 5, and this is minus, this is plus and this is minus. So x cube 20 divided by 6 is 3 point something. 20 divided by 6, 3.33 equal to, so you can consider 5. So x cube equal to 5 divided by 3.33. .50. Now x equal to cube under root 1.5. This is equal to 1.14. So this distance equal to x equal to 1.44. 1.44 47 meter. X equal to, and this remaining, this is equal to 1.855 meter. This is your expected answer. Oh shit, so we forget this 2 because we h equal to 20 divided by 3 and this is 2, so that's why these answers slightly change. Twenty divided by 3 divided by 2 divided by 3, 1.11. Right. This is equal to x equal to 5 divided by 1.11. This is 6 and cube under root 6 equal to 1.65 meter. This x equal to 1.65 meter and this is remaining 1.35 meter. So this is nature of the curve. Likewise, so next problems we'll see is the when shear force diagram given, draw load diagram. So this is different type problems. For a simply supported beam AB, for the simply supported beam AB, the shear force diagram is the shear force diagram is shown in figure. Draw load diagram. Draw load diagram and bending moment diagram. And bending moment diagram. For this beam. 4 meter, 2 meter. Meter. This is 2 meter. 21 and 3. This is 3 kilonewton. This is 21 kilonewton. Downwards 18 kilonewton. And this is 18 kilonewton. A point, B point, and this is suppose C point. So by observing shear force diagram, it can be concluded RA equal to, this is RA equal to support at A point, this is equal to 21 kilonewton, and this is inclined load, so that's why at B point, because this is on a vertical line, at B point (18 minus 3) or 3 minus 18 equal to 15 kilonewtons, and this is downward force. And at C point 18 minus 0 equal to 18 kilonewton, this is upward. So that's why this is simply supported beam, and this inclined line indicates this is uniform distributed load, A point, B point, and this is 15 kilonewton, and this is uniform distributed load. Now UDL equal to, this is C point, UDL between A and C point. Now intensity at of UDL at C point minus UDL intensity of UDL at A point, right, divided by so this is UDL intensity equal to, or shear force, you can intensity instead of the UDL, divided by distance between AC point. That's why this is 21 C point minus 3 minus this is 21 divided by 4. So I think correct. So this is positive, because this is positive and this is negative. So that's why this is 24 divided by 5 equal to minus 6 kilonewton, and this is per meter. So that's why you can write, because this is why this is negative sign, because this is downward. So that's why this is 6 kilonewton per meter. Now draw, this is load diagram. RA equal to how much? 21 kilonewton, and RB equal to 18 kilonewton. Now bending moment calculations. Bending moment at end points equal to 0. So bending moment at C point. So clockwise 21 into 4 minus anti-clockwise 6 multiplied by 4. So this is shear force, distance 4 divided by 2. This is 84 minus 24 into 2, 48. So this is 36 kilonewton meter. And this is positive, but this is uniform distributed load. So that's why it's a bending moment diagram. C point, A point, and this is B point. Here suppose this is 36 kilonewton, and this is straight line. Why this is straight line? Because this is, there is no any, and this is, nature of the curve is the parabolic curve, and this is maximum bending moment, because so actually such type of the, and here you will get maximum bending moment. So this distance equal to x, and this is 4 minus x. So maximum bending moment equal to x. This distance is to be calculated. So where shear force change, suppose this is x and this is 4 minus x. So that's why by comparing triangle, (21) divided by 4 minus x equal to 3 divided by x. 21x, this is 12, 4 into 3 into 4, 12, minus 3x. 18x equal to 12. This is equal to 0.66 meter. This distance equal to 0.66 meter. So that's why maximum bending moment equal to remaining distance. This is 3.333. Maximum bending moment equal to 21 multiplied by distance 3.33 minus 6 into distance 3.333 multiplied by moments 3.33 divided by 2. Now we request calci. 21 into 3.333. This is 69 point. Suppose this is 70 minus square divided by 2 into 6. This is 33.33 minus 70. This is equal to 36.66 kilonewton meter. And this is 36 and this is 36.66. This is 36 kilonewton meter and this is 36.66 kilonewton meter. But this is correct bending moment diagram and this is maximum bending moment. Again one problem, so we will see shear force diagrams for the beam, draw load diagram and bending moment diagrams. So you should, if you can calculate, means by observing shear force diagrams, you can calculate, means you can draw shear force load diagrams, means you are becoming as a perfect mechanical engineers. So try to understand this. 2 meter, 1 meter, 2 meter, 1 meter, 2 meter, 7 meter. 2 meter, 2 meter, 1 meter, and this is 2 meter. Right? A, B, C, D. A, B, C, D and E point. 20, 10, 20, 20. 20, 10, again 20, 20, 20, 20, to that 20. Again this is 20. So after that, this is 0. This is 20 kilonewton. This is shear force diagram. Right. Supported beam AD, because here this is now here RA equal to 20 kilonewton, because this is straight vertical line, so that indicates, and this is upward force. At B point, this is downward 0 to 10. 0 to 10 means this is 10 kilonewton, this is, that's why downward. At C point, this is 20, this is 20. At C, minus 10, minus 20. All right. So this is equal to, again, because minus 10 to 10 10 kilonewtons downward. Minus 10 minus this is considered, so that's why minus 10. Next, again at a D point, minus 20 minus, this is 20, this is equal to 40 kilonewton. But this is upward, na? This is upward, so that's why actually this is plus 20 minus 20. So that's why this is 40, because this is downward force, plus 40. And this is support, vertical. This is vertical and this is downward. Here downward at B minus 10, this is minus 10, and at E point 0. So by this using this data, you can draw shear force diagram. A, B, C, D, E. A point 20 kilonewton. At a D point 40 kilonewton. Right at C point, and at B point 10 kilonewton. At C point again 10 kilonewton. Now A to B UDL. A to B UDL means here you can write change in shear force, change in shear force between 2 point divided by distance. Briefly you can write, so that's why UDL distance equal to 2, this is 10 kilonewton meter, and UDL DE equal to again 20 minus 0 divided by 2, this is 20 kilonewton per meter. (10 kilonewton per meter). This is also 10 kilonewton per meter, because this inclined line indicates this is UDL acting. This distance 2 meter, 1 meter, and this is 2 meter. So that's why bending moment calculation. Bending moment at A point equal to, because this is end point, equal to 0. Bending moment at B point, now briefly I am writing MB, and this is equal, because limitations about the time, 20 into 2 minus 10 into 2, and distance divided by half of its distance. This is shear force, half of its distance. So this 2 will get cancelled. 40 minus 20, this is 20 kilonewton meter, and this is clockwise. Bending moment at C point. So this M stand for bending moment at C point. 20 into 4 minus 10 into 2 shear force, half of its distance plus this distance 2 meter equal to, this is 80 and this is 20 multiplied by 3. So again this is 20 kilonewton meter clockwise, because this is 80 minus 60. Bending moment at D point. Distance increase 1 meter. 20 into 2 plus 2 plus 1, 10 into 2, 2 plus 1, and here additional one moment, that is 10 into 2. So this is equal to 0 kilonewton meter, because this is anti-clockwise moment. So that's why minus 10 into 2 plus 1 minus 10 into 1. Right? This is 500. This is 4 minus 80 minus 30 minus 10 minus 20 kilonewton meter. So at end point, bending moment at E point. So this should be 0. So only for checking purpose, 20 into 2 plus 2 plus 2, right, minus 10 into 2, and this 2 plus 1 plus this distance additional 2 meter minus this is 2 20 into 10 into, right, again 10 into 2 plus 1, alright, this is 30, this is 20, right. Third moment, 10 into 2 plus 1 plus 2. Fourth moment, 10 into 1 plus 2, and this is RD plus 40 into 2. 140 minus 20 into 6, 120 minus 500 minus 30 plus 80. So this 140 plus 80, 220. And again here this uniform distributed load, this 40 into 80. So I did any mistake. 2 plus 1 plus 1, right, that is 10 into 2. 10 into 2 plus 1 plus 2. Oh, I did mistake here. This is 50. minus UDL 10 into 2 divided by half of its distance. And this is 2 divided by 2. Here you can consider 10 into 2, 2 divided by 2. So this is equal to minus 20. 20 into 2, right. So this 140 and this is 220. 120 and this is equal to 0, right. So that's why bending moment calculation is bending moment diagram. A point, B point, C point, D point, and this is E point. Bending moment at B point 20 kilonewton. Suppose this is 20 kilonewton meter. Bending moment at C point 0. Bending moment at D point 20 kilonewton. And bending moment at E point. So that's why this is straight line and this is sit, because this distance 2 meter and this is 1 meter and this is passing through, and this is C point, and here this point is the point of contraflexure. Now this distance equal to, suppose, x. Alright, and this is 1 minus x, and this is straight line. One minus x, or this is equal to, you can consider this distance equal to, because this is x and total this is 3, so this is 3 minus x. Alright, so by comparing triangle, (20 divided by x), again 20 divided by 3 minus x, 60 minus 20x equal to 20x. So 40x equal to 60, x equal to 1.5. So this distance equal to 1.5. That's why this distance equal to 0.5 meter. This distance equal to x equal to 1.5 meter. This is your expected answer. So in my solutions, this is not solved, but this is the point of contraflexure. So due to limitations of the time, I'll stop here. And in the next class, we'll see some of the problems again related with the shear force bending moment diagram. And after that, we can see any theory related with the, again I will engage minimum 2 to 3 class that is on the shear force bending moment diagram. So in this week, I will complete this chapter. That's why today I stop here. Thank you.